Video games. Whether you haven't or haven't consumed the media, you probably have heard of them before. According to the Merriam-Webster, a video game is an electronic or digital game played by manipulating images on a television, computer, monitor, or screen via an input device. While for the most part, video games are user-friendly and accessible to everyone, making a video game is the exact opposite. There's no magic behind video games. The real magic is the math and science behind the coding of the passion project. Whether you are flying through the sky, shooting an alien, driving a race car, it may not seem like it. You are actively participating in applicable mathematics, whether you know it or not. There are millions and millions of games out there. And in order to talk about how math and video games are basically interchangeable, we unfortunately can't talk about every single video game there is. Rather, we should probably just focus on one video game and show how the mathematics are used prominently and how they're used in the physics and the mechanics and the rules of the game. So I figured, what better way to explain evident mathematics in video games than using everyone's favorite, Minecraft. Minecraft is one of the most played games of the modern day. With over 185 million active users, it's safe to say Minecraft is a popular game. But Minecraft is unique because it has an impressive amount of hidden mathematics that build the world into a fun survival craft experience. That is Minecraft. You may be wondering, what kind of math is prominent in Minecraft? What math even is remotely associated with the act of mining sticks and punching wood? Well, let me tell you. The mathematics in Minecraft start right even before you get into the game, when you're generating your procedurally generated world. All Minecraft worlds are made up of 16 by 16 block-wide chunks. A chunk is 64 blocks. So by that math, we can stretch the full height of the dimension, and we can find out that there are a total of 18 quintillion possible worlds that can be generated using randomness, algorithms, and some manually built decorations. When you generate your Minecraft world, Minecraft uses random numbers generated to form a seed. Every world has a seed. Your seed is random numbers that basically make up your world. It's completely chaotic and usually lacks continuity. So Minecraft does this cool thing in order to solve this problem. And this is where our first example of prominent math is being used. Minecraft uses a noise gradient algorithm like Perlin noise in order to make a world with continuity and not chaos, but just randomness. I'm going to do my best to explain the Perlin noise, but bear with me, it is rather complicated. So first off, let's look at some noise. This is what we think of when we think of just regular noise. This is an array of randomly generated values. There's no pattern, and it's pretty random, it's discontinuous, and we couldn't really use this right here to generate a smooth terrain. However, this is Perlin noise. While it's still random and behaves pretty unpredictably, it's smooth and its continuous texture makes it so we could actually use this to generate some terrain. Based on the coloring here, we can actually turn our Perlin noise into a topological map with peaks, grasslands, and ocean. So how do we even get noise? How does that even work? What is that? So Thanks to a 1985 paper by Ken Perlin, he describes his noise generation algorithm as a way to use for generating random natural textures, mainly for computer graphics. So here's how it works. First, you instead of starting with an array of random numbers, we begin with a coordinate of random vectors. Perlin noise is generated on a per pixel basis, like chunks. So we'll take each pixel in our map and map it onto the vector grid. When we do this, we introduce our first parameter, scale. In the context of Minecraft, this basically allows us to modify how terrains and biomes work in the grand scheme of our world. So we can map out where certain beaches are, mountains are, and our whole world isn't just forest. So then what you do, depending on the size and terrain, the size of the desired output, we may need to expand the tile grid and ensure it's large enough to map everything. Our Minecraft one is massive, we're fine. So then, plotting one of the pixel coordinates on the vector grid, we can now work out a distance vector from the point to each of the bounding corners. So then what we do is we take the dot product of each gradient vector with the corresponding distance vector, and we produce 4 numbers, one for each corner. So we're almost there. So now to calculate the final noise for this pixel, we interpolate between the 4 corner values, first horizontally, then vertically. This ensures a point closer to one of the corner's vectors is influenced by it more than the other vectors. Once all values have been generated, the final step is to normalize the values to be in the range 0, 1. This gives us the noise map we saw before. 3D noise is a fundamental application used in all world generation related to Minecraft. Whether it's just base terrain, caves, peaks and valleys, or even veins of ore. Perlin noise is a mathematical concept that, without it, Minecraft would cease to exist. Side note, it's important to know that Minecraft overworld generation is not just noise or any just noise parameter. There's a lot to go into making a real world that has biomes, temperature, humidity, continentalness, erosion, and weirdness and depth. But those parameters are all decided on the grand scheme of the seed. I have here pulled up the debug screen, which you can find by pressing F3 on your keyboard, so you can actually see where you are. For example, temperature is on a scale from -1 to 1. Continentalness is from 1.2 to 1.0. By those ranges, those tell if it's a mushroom or if it's an ocean. Here's a graph of the peaks and valleys. But yeah, this is just little things to make the Minecraft world an actual world and not just terrain. So that's how you build the Minecraft world. Overall, it's a large-scale project, but really if we tear down the walls, we can see that it's not that difficult to understand. Matter of fact, let's look at those parameters in Minecraft's own debug menu. So we are on a coordinate. We are on an XYZ plane. This is important because that is the parameters on our Perlin noise. We can find these 3D shapes and translate them into real world generation. If you press F3, you can see your exact position in real time. You can also illuminate the chunk border. We can even see where this 16 by 16 block is on the map. So we can even relate that back to our Perlin noise. These are pixels. These are all formulated to create a cohesive world. So even though Minecraft feels organic and it feels like a regular natural forest, it's actually a pretty understandable mathematical grid.